Okay, now, okay, in a loop, the loop, right? A car goes around a vertical circular loop at a constant speed. The car has a mass 500 kg and moves with speed 20 meter per second. The loop has a radius of 20 meter. Okay, what is actually loop the loop? Let's Google. This is the loop. You see that? You see before this roller coaster. Loop the loop. Loop and the loop. You see that? Loop the loop. You see, oh, how many loop the loop? Wow. Have you been here before? Loop the loop? Yeah? Guess not. Yeah. Okay. So maybe one day you can go there, right? If you earn enough money. All right. So this is called the loop the loop. So you can see. Okay, so this is the loop the loop. Okay, as you can see over here, the roller coaster is upside down. What is important here, I want to show you that there is a point at the top here. The loop the loop is upside down. The roller coaster is upside down. So the normal force, in this case, the normal force is downwards instead of upwards like the Ferris wheel. Okay, so maybe let us transfer this picture into our slide there. Okay, all right, for a second. Look carefully this one. Yeah, I transfer to here already. That's the difference. Last time you for Ferris wheel, yeah, in the previous video you already learned about the Ferris wheel. So like this one, the normal force, like if you're at the top position here, at the top position, your normal force, your seat, yeah, the normal force is provided by the, you know, we know the normal force is provided by the seat. Okay, it's provided by the seat. Remember that, yeah, your normal force provided by the seat. So you are not upside down. You are, you know, this is not upside down. You are in your original form. In your original form. So this one, your normal force is going upward at the top position. Okay, your normal force is upward because you are in your original form. But this one at the top position, yeah, at the top position here, you are actually upside down. Yeah, have you been to roller coaster before? Have you been to roller coaster before? Okay, this is also called roller coaster. Yeah, loop the loop, or you can say it is a roller coaster. For roller coaster, at the top position, you are actually upside down. The car is actually upside down. So your normal force is downward. Your normal force is downward. Okay, that's the difference. That's the main difference between these two. Ferris wheel, you are not upside down. You are sitting upright. Yeah, you are sitting upright. You are sitting upright. This one you are, or you can say inverted. Yeah, you are upside down. You are upright. This one you are upright. You are upright. So your normal force is upward. Your normal force is upward. But loop the loop or roller coaster, you are upside down. You're upside down. So your normal force is downward. The seat exerted downward. Sometimes this normal force is for the passenger is called seat. But for the car, sometimes this normal force for the car is exerted by the track. Okay. So normal force exerted by the seat or normal force exerted by the track. The track is making upside down. Yeah. So this normal force can be exerted by the seat or exerted by the track. For the car, the normal force is exerted by the track. But for the passenger, the normal force is exerted by the seat. Okay. And Ferris wheel, the normal force is upward because you are upright. You are upright. But for the loop or roller, the roller coaster, you are upside down, so your normal force is downward. Just remember the difference between these two. Yeah, one normal force is upwards, roller coaster normal force is downward. Okay. So now let's go back to the questions here. Okay, so this is the loop, yeah. Normal force is upside down. Okay. Okay, so the loop goes around the vertical and circular loop at constant speed. The car has a mass, okay, and a speed and radius given all. Now let's do one by one. Let's do the question A, yeah. What is the magnitude of normal force? Okay, it asks about the normal force on the car. Okay, all right. This is the normal force on the car. This one is, if you say normal force on the car, this one is normal force from the track. Okay, the track, okay. If on the car, that means this is normal force from the track. If normal force on the let's say if it is the if the question says normal force on the passenger, then this one is normal force from the seat. Okay. Yeah, if on the passenger is normal force from the seat, but if on the car is normal force from the track. Yeah, that's the difference. So what's the normal force on the car when it is at the bottom? Okay, it's at the bottom of the circle. Okay, at the bottom of the circle, so that means at the bottom here. Okay, so we can imagine. Let's draw out the the roller coaster. Okay, the roller coaster. Let us draw it out. Okay, you can maybe draw out circle. Okay, track. This circular track. Yeah. Okay, just draw the track. The loop. Okay. So now okay. So now what is the normal force on the car? So the car now is at the bottom. Okay, at the bottom. The car is at the bottom here, right? At the bottom, on the bottom. Okay, so question A is at the bottom, right? Okay, at the bottom is over here. So okay, what are the forces? So the center of circle is at the top of the car. At the top of the car. So the car is at the bottom. So what is the force exerted on the car? It has the weight. Of course, it has the weight, but it has the normal force directed upward, because from the track, this normal force from the track. Okay. Now, what's the centripetal acceleration? The centripetal acceleration is towards the center of circle at the top. So the centripetal acceleration towards the top, and follow acceleration is positive, opposite acceleration is negative. Okay, follow acceleration positive, opposite is negative. Okay. So okay, so now how to do this? How to do this? So total Fy, this is in the y component. Okay, in the y component we have acceleration. That means we have resultant force in the y component. Okay, in the y component we have the acceleration. So since it has acceleration in the y component, means it has resultant force. Total force equal to ma. So this is actually the centripetal force. The resultant force is actually the centripetal force. Okay, so normal force is positive because follow acceleration. Okay, so just write that down. Normal force is positive, but the weight is opposite acceleration, is negative. Negative the weight. The formula for AC is V squared over R. We use VR, so we use V squared over R. So mv squared over R. Okay, and then normal force minus W is mg, mv squared over R. So normal force equal to this one mg plus mv squared over R. Okay, so let's calculate, put in all the values. What is the mass here? 500. Okay, let's put in the 500. 509.81 and then plus on 500 V. What is a V? What is a V? 20 square. Yeah. R. What's the R? R. 20 meter. Okay. 20 meter. So calculate. Let's calculate. Okay. So the answer is 14905 Newton. Okay, that's the normal force at the bottom. Now, is it correct? That's correct. Yeah, that's correct. Okay, that's correct. All right. So next one. Okay. Now B. What is the magnitude of normal force at the side of the circle? Oh, at the side. At the side, asking for normal force. At the side, that means over here. Yeah. Over here. How are you going to draw it? Maybe I should rearrange. Okay, I rearrange already. Yeah. A just now is at the bottom, so this is a calculation. Now for the side, it should be over here. Yeah. So at the side, let's do for the side. B. Okay, sorry. B. Yeah. B. So at the side, so that means the car now is where? Where is the car? The car is over here. Okay. So like that. Should be like that. Yeah. Okay, over here at the side. So let's draw the free body diagram first at the side. So what do we have on the side? The forces. What force do we have? We have this is the point mass. The normal force is, you see this track is over here. You see the track? This is the track. This is the track. This whole thing is the track. Yeah, this whole thing is a track. Okay, so what are the forces acting on the block? We have the weight. Okay, the weight going downward. You know, this is the track. Yeah, the track. This whole thing is the track. Yeah, this whole thing is a track. See that? So the track is at the right hand side here. So of course, the normal force must be perpendicular to the track. The normal force must be perpendicular to the track, 90 degrees to the track. So it's this way. Perpendicular to the track. Okay. So where's the centripetal acceleration? Towards the center of circle. So centripetal acceleration should be to the left, because towards the center of circle. The center of circle is at the left hand side. Okay. So follow acceleration is positive, opposite is negative. Okay. All right. So at the side here, we use what component? We use x component. Yeah, we use x component. Why? Why do we use x component? Okay, let's look at this. Why do we use x component? Because x component has the centripetal acceleration. So let's do it. Yeah. We use x component because it has the centripetal acceleration. So this is total Fx equal to ma. MAC, which is the centripetal force. So we have the normal force there. We have the normal force there in the x component. So this normal force is positive because it follows acceleration. Okay, normal force is positive because it follows acceleration, and the AC is v squared over r. So the normal force here is mv squared over r. So let's plug in all the values. The mass is 500. Okay, mass is 500. I think we already have that over here. This one lah. Just use this one. Hey, sorry. Copy this. Over here. It's the same. Yeah. V is 220. R is 20. Right. V is 20. R is 20. Yeah, that's correct. So let's calculate this value. All right. Let's calculate this value and see. Okay, let's calculate this value and see. So I got the normal force is, the normal force at the side is 10,000. 10,000 Newton. Okay, that's the normal force. the side. Normal force 10,000 Newton. Okay, so that's a side. How about, is it correct? Yeah, that's correct. Okay. Now, what about the magnitude of normal force at the top? This one is at the top. Okay, normal force at the top of the circle. So top of the circle. Now let's draw for the top. Okay, at the top here. Now at the top. Just now at the side. Now at the top. Yeah, now at the top. So how? I think I should rearrange everything. Yeah. Hold on. Give me a second. Yeah. So just now this one is correct. Yeah. 10,000 Newton. Now I want to find the top position. So at the top position here, I need to draw the, first of all, need to draw the free body diagram. Okay. So this is the point mass. Okay. And the weight, we have the weight of the object. The weight of the object is downward. Okay. But you see the track is at the top. You see that? You see the track at the top? So the normal force is downward. The normal force is downward. Because the track at the top, the normal force is perpendicular. The normal force, the normal force is always perpendicular to the track. So the track is at the top. Yeah, the track is the track is at the top. So the normal force, that's why it's downward. Yeah, unlike the Ferris wheel. Ferris wheel, you are not upside down. You're not upside down. The seat is at the bottom. The seat is at the bottom, so your normal force is upward. This time the track is at the top, so your normal force is downward. Okay. So let's look at this question. So your track is at the top, so normal force is downward. So where is your centripetal acceleration? Your center of circle is at the bottom, so your centripetal acceleration is also towards the center of circle. Towards the center of circle, which is at the bottom, so that's why your centripetal acceleration is downward. So follow acceleration is positive, opposite is negative. So now we apply Newton's second law. Yeah, Newton's second law. So see, we are doing the top position. Yeah, now we're doing the top position. So we also doing the y component. Yeah, this one we do y component. Just now, this one x component. Just now this one is in x component. Yeah. Just now this one is in x component. This one bottom at the y component. This one also use y component because the AC and centripetal acceleration is in the y component. Okay, so this one we use y component. Y component. So my total Fy. Okay, my acceleration is in the y component. So my resultant force in the y component. So MAC. Equal, this is the centripetal force. Okay, so what force we have in the y component? We have the weight and the normal force. Both of them are same direction with acceleration, so both of them are positive. So both of them are positive. W plus n, because both same direction with acceleration, both are positive. Acceleration is v squared over r, so become mv squared over r. So normal force, to get the normal force is, this one is mg. W is mg, so go to the other side, become negative mg. So mv squared over r minus mg. So what do we get from here? Right. So what do we get? Okay, let's substitute all the values. We have this one, yeah, now this one. Okay, just copy paste over here. Yeah, make it a little smaller. Yeah, this is mv squared over r. Where is the mg? Meg minus mg, 500 times 9.81. So what's the answer? What's the answer? Okay, so this one, the answer is 5095 Newton. So that's a normal force. That's a normal force. Okay, normal force by the track. Okay, so you see, which one has the lowest normal force? compare the top and the bottom, which one is the lowest normal force? At the top. At the top. You see that? At the top as the lowest. So at the lowest normal force. Okay. Sorry. Lowest here. Here is the lowest. Here is the highest. The bottom is the highest. It's the highest. So what I can say is, as you decrease the speed, yeah, if the car moves slower and slower, the speed is this one, yeah. This is the speed, yeah, the speed. If this speed moves slower and slower, yeah, that means becomes slower and slower. Okay, what I can say is, this one slower and slower. This one you okay, you still have mg, yeah. You still have mg, so it's still safe, yeah. At the bottom here is actually safe. Bottom here is actually safe, but it is unsafe at the top. At the top position is unsafe. You know why it is unsafe? You know why it's unsafe? When the speed decreases, the normal force decrease. Yeah, the normal force decrease. At certain value, when it decrease until n equal to mg minus mg, that means the mv squared over r, now the value mv squared over r become equal to mg. Yeah, when it decrease until certain value of speed, when mv squared equal to mg minus mg, you get 0. That means that point, if you are if the car is moving too slow, I mean the speed of it, the speed of the car, if it's moving too slow, the speed of the car moving too slow, okay, moving too slow, when mv squared become mg minus mg becomes 0. This means at this point it lost the contact from track. It means that the car will fall. The roller coaster will fall if too slow. Understand or not? If the speed is too slow. If the speed is too slow, the car will fall, especially at the top position is unsafe because it has the lowest normal force. Lower speed, the lower the speed, the lower the normal force. The normal force will reach 0 at certain point. It reaches 0 when the mv squared over r become mg. Because mg minus mg, you get 0 normal force. 0 normal force, that means you lose contact from the track, and the car is not, the car is not in contact with the track anymore. Then it will fall. That is accident will happen, yeah. The roller coaster, if too slow, it will fall. Because the track do not provide normal force anymore. The track do not provide the normal force anymore for the car. You're not in contact with the track anymore. The car will fall. Okay, if too slow. Okay. So that's why the question D asks for what is the minimum speed. What's the minimum speed so that the car still stays in contact with the track at the top position. That's why I say the top is unsafe. Okay, stay in contact with the track. So talking about track, we talk about normal force, yeah, because the track provide normal force. So what's the minimum speed? So how to find the minimum speed? Okay, how to find the minimum speed? So to do these questions, yeah, we do over here. So the minimum speed, V is minimum. Okay, V is minimum when normal force is 0. Remember that. V is minimum. V is minimum when normal force is 0. That is the point when the car lose contact from the track. Okay, so normal force equal to 0. So okay, using these equations from here, okay, so normal force equal to mv squared over r minus mg. So normal force becomes 0. So mv squared over r minus mg. So you see that mv squared over r equal to mg at that point. You see that? That's what I say about this. You see that? This one, mv squared over r minus equal to mg. So you can cut. I can cut this. And then you can find the equation for v some more. This is rg. And then I square root because v squared becomes square root. That is the minimum speed. The minimum speed formula is square root rg. The minimum speed formula is square root rg. So what's the answer? Square root rg. How to find the minimum speed value? So the r is 20 meter, and yeah, 20 meter times 9.81. So what's the answer? 20 times 9.81. It is the minimum speed is 14.01 meter per second. That's the answer. Okay, is that correct? Yeah, 14.01. That's correct. Okay, that's correct. So that's the answer. Okay, for the rest, 509. Yeah, is also correct. This one. Yeah. So the rest also correct. Yeah. So that's the minimum speed for the car. Okay, that's the minimum speed. So if the car travels less than, if let's say the speed of the car less than the minimum speed, which is 14.01, maybe I move at 13. You know, the car will fall. The car will fall from track at the top. You know, the car will fall from track at the top. Not enough normal force, not enough speed to have the needed normal force. The car will fall. Too slow. This is why I say 13 meters per second is too slow. If you want to maintain the car on the track, you must have at least speed with 14.01 meter per second. Okay, if less than that, like 13 meter per second, the car cannot maintain on the track. It will fall down from the top position, and accident happen. Accident will happen. Okay, that's what I want to say about the top position. Yeah, it has a minimum speed, and you can see some more here. This minimum speed is independent of the mass. So if you increase the mass, use a bigger car, your speed is constant. Your minimum speed needed is still constant. Either is independent of the mass. Independent. The minimum speed is independent of mass of car, because there's no mass. You see that in the formula for minimum speed, there's no mass there. So you use whatever mass of roller coaster. You use a big car or a small car. The minimum speed needed is independent of how big the car. Independent of the mass of the car. It only depends on the radius of the circle and the gravitational pull. Okay, it's independent of the size of the car, mass of the car. Yeah, the minimum speed needed. Okay, so that's all for this video. Thank you for watching. Okay, that's all. Yeah, the top, bottom, side, and the minimum speed. Okay, the top has the lowest normal force, the side medium, the bottom has the highest normal force. And so because the top has the lowest normal force, means it is the most unsafe. Okay, so that's all. Thank you.